Okay, so let's go through this. Number 1. Okay. What do you guys get?
C.
Okay, it should be C. Now, let me tell you why it is so. It's go on 2 points that you have to remember. You're adding distilled water, right? Okay. You want to remember that if you add water to the weak acid, it will increase the ionization. So if you guys needed to, I would add it on the side, right? Diluting.
Wait, so if you add it to a strong acid, does it matter because it's trying to dissociate completely anyway?
There you go. Perfect. Diluting weak acid equal increase percent ionization. Okay. If you guys are wondering how this happen, the way it's gonna happen is because of this. You know that if you look at this, to write K value, you're gonna have H plus, F minus, and then you have HF there. Okay. Since you're not calculating K value after you dilute it, you're gonna be calculating Q value. But here is the caveat over this. When you dilute it, you guys are thinking this concentration is now decreased. Agree? Decrease. But how about these two? Concentration. They must also decrease as well, right? Because you're diluting it, you're adding water to it. So these two also decrease. Guess what happened? Internal mathematical value. Your Q is gonna be even more smaller than the K. Because your top is decreasing much more faster than the bottom, right? Think about it that way. If I have a number, let's say, I don't know, 5 divided by 3, right? But instead of 5 divided by 3, what if we are getting, I don't know, 20 divided by 6? You can kind of see that? Because on the top, I actually multiply by, or actually, sorry, I have to decrease it. So instead of that, let's say I want to decrease it. Instead of 5, I say 1.5, and then this is instead of 3, I said, I don't know, 2 or something, right? So you can kind of see that it is decreasing both number, but the top number is decreasing much more rapidly. So overall, if you think about it, that Q is smaller than K, right? If Q is smaller than K, which way the arrow is pointed? That way, shifting. So we're gonna make more of the iron. So if you're not sure about how this other thing I wrote, you can actually remember this. Diluting the weak acid means increase the ionization. Make sense? Okay. What do you guys think about weak base?
Same thing.
Same thing, right? Yeah. Okay. Now take a look at on this side. You are adding KF into HF. They decrease the ionization. Why?
Because it's
yeah, this side is decreased because it's common iron, right? Common iron F minus is added, right? Which means if you add common iron, what's gonna happen is gonna decrease the ionization. Easy. Number 2. What do we get?
yes. What?
It was A. Let's take a look at this.
Oh, because
Okay.
NaOH is a strong base. Oh.
Okay.
Yeah.
Which of the mixture would create a buffer solution with a pH approximately 4? Take a look at what we're having. We're trying to create a pH solution. And we're trying to create buffer. What is buffer again?
It's
base plus conjugate acid plus conjugate base or base plus conjugate acid.
Right. Either one of them. It's acid plus conjugate base, base plus conjugate acid. Now notice that we need conjugate. That means initial acid or base is a weak acid. If you look at it, all of these are weak acid. Agree? So to make it into buffer, I need a conjugate base. So how do you gonna get conjugate base? Well, you gotta react your acid with a little bit of base to make it conjugate base, right? So you have in the beginning you have A and B to be going about. So now you might say, Michelle, why do I pick an A and not a B?
NaOH is a stronger acid. I mean base than H.
Right. Because if you have the same amount, that will be at the equilibrium buffer, right? So that would be equivalent point, which means the pH should be greater than 7, We're looking for pH 4, so we're not looking at B, right? B is actually at equivalent point. This is at equivalent point. Now, do you know why I can tell it was equivalent point?
Equal amount.
Equal amount of H plus and OH minus, right? In this case, pH will be greater than 7 because you having a weak acid plus strong base, okay? Now, this is a halfway point, so halfway point should have been work, right? And plus, that's only one that we need. Kind of make sense? Okay, look at number 3. Question about number 3. What do we get? Okay, let's take a look. Okay, so I have equation, let's see. You have 100 milliliter of this solution and 100 milliliter of this solution, okay? By the way, make sure you notice that's the acid. That's gonna make conjugate base because Na doesn't matter. Stir, pH is measured to be this. After 3 drop of HCl is added, pH of the solution is measured is still this, which is the following equation presents the chemical reaction that's account for acids was added, but no detectable pH change. First of all, remember what I said these two. Acid, conjugate base. So what are we having in the first sentence that we're talking about? It's a buffer. Obviously, that's the reason why I adding HCl not even moving. So let's talk about what's happening. Okay, so clearly you guys are talking about either C or D. Take a look. Buffer solution. So that means HCl is acid being added, which is the same thing as H plus added. Yeah, or you can say H3O added. So what is H plus is gonna do?
It's gonna
React with the conjugate base.
It got to react with conjugate base, right? So acid gonna react with conjugate base so that your pH doesn't change. That's how it's gonna be able to resist the pH change. So the correct answer for this is C, because acid, conjugate base. Make sense? Yeah. I mean, A and B doesn't make any sense, right? Now, what if instead of this question, I change it and I said I'm gonna add NaOH? Okay, what's gonna happen? Okay, so if I change the question into saying, let's say, NaOH added. I'm using different pens so that we can kind of see what would be the reaction equation you think is gonna happen. I'm being double advocate. What do you guys think? Who is OH is gonna react with? Yeah, it's gonna react with acid and then it's gonna make a conjugate base. Try right here. We're in the middle of the testing here. Yeah. Okay. So, question about this? How's it going on about? So if you were to try to write it, remember, NaOH is just gonna make OH minus. So that means OH minus is gonna react with, right, what's it called? C2H3O2, right? In a way that it's gonna end up making, right, H2O plus C2H3O2 minus, right? That's what we kind of expecting, right? That's what is gonna happen. Kind of makes sense? Okay, let's go with number 4. What do we get for 4? Yep, 4 is a D. Okay, now you guys should all understand what's gonna happen in, right? So solution contain equal amount of this and this. Take a look. Acid, conjugate base, pH is this. Okay, 5 milliliter of concentrated KOH is added to dissolution. Which of the following most accurate account for the species is greater concentration and pH of this? Okay, notice the pH that we're talking about. Since we're adding what? What are we adding?
strong base.
Strong base. What do you think this pH will happen? It will go up. right? That is only makes sense. It cannot go down. If it's going down, we're crazy. Okay, so these two are wrong, and then now we're gonna have to think. Okay, what is basis gonna do to these guys? Right, this is gonna react with this. That means this concentration should go down. Make sense? So that means the number that is greatest should be
Basic.
this guy, the conjugate base.
Basic.
Make sense?
Basic.
Yeah, it's basically basic. Yeah. Okay? Make sense? So this is a conjugate base. Make sense? Because base react with this. So this guy neutralize the acid, right? Because this is a base. Make sense? Question. Okay. The same could go, instead of giving you KOH, I can give you HCl and ask you this question. Be ready for that. Make sense?
No.
Okay. Number 5. See, this is how you study them, because you can't just study one way. You have to think about what is another possibility. Okay. Number 5, what do we get? Okay, good. It's A. All right. So take a look at point R. Okay. First of all, let's talk about the main point in there. Where is my equivalent point?
All the way.
It's up here, right? Oh, no, not here. Sorry, here. Sorry, wrong one.
Yeah.
That is equivalent, right? Sorry, wrong point. Yeah, equivalent point right there, not labeled this, right? Okay, now, where is my other important point? There's another one. Your halfway point, right? So your halfway point is probably this S, right? This is my halfway. Okay. See what I'm saying? Okay. So you are titrating a weak acid. Also remember that you are titrating an acid. Yeah. And I said that HA is weak acid. Why did I say this HA is a weak acid? I said it is a weak acid.
Oh, because.
How do I know that?
Equivalent point is a little bit basic.
Right. At equivalent point is basic. It's greater than 7. Right. If it's in 7, we know that this is a strong acid. Right. Because strong acid, strong base, pH is gonna be 7. Weak acid, strong base, the pH is above 7. Okay. How do I know strong base?
Because it's a little bit basic.
Right. I told you it's NaOH. Right. Yeah.
What if it was
Alright.
weak base?
That calculation is a lot complicated.
And we get into complicated.
Yeah, we can do that. It's just you have both K and KB to account for at the same time.
Oh my god.
All right, now let's take a look at R. R is before the halfway point. So what do you think is mostly going to be in there? It's going to be acid, right? Because you still have a lot of acid. Because think about it. At equivalent point, all the acids is gone, right? At halfway point, acid concentration is equal to conjugate base. Remember that one?
What about T? It's the opposite.
T will be opposites of R. Yes, agree.
Or NaOH.
Not NaOH. More conjugate bases, A minus. Okay, make sense? Because halfway point concentration of HA is equal to concentration of A minus. Okay, so before that is more HA, after that is less HA. H minus. Yeah. Yes. Yeah, because that's how much it's gonna neutralize. So whatever left over. Yeah. Good question. All right, 6. What do we get? B. Good. All right, you all should know B because we already just talked about it. Right? Take a look. U is what?
Way past it.
Way past titration.
Oh, yeah.
So that means you should have NaOH floating around. But remember, NaOH is a strong base, so therefore they're gonna be split. Okay? The only one that has NaOH is B. B is the only correct one. Make sense? Alright,
B.
let's look at 7. Ooh.
It's probably C.
At which point
It's probably C.
it's probably C. Explain.
The A is closest to tricep of HA. So
Okay.
A is going to be more than HA.
Right.
A little past halfway.
Right. Remember, where did I talk about where A would be more than HA?
When,
Half.
yeah.
After the halfway. Okay? And before the equivalent point. Because at the equivalent point, what did we get?
No.
No.
No HA. HA is 0. Make sense? Yeah? Because at equivalent point, HA concentration is 0. Or I can say very small because remember A minus might go back and make HA. But initially is 0. We agree? You know, we can say about 0. About. Because it will go back and make some. Yeah, which make your calculation a little bit complicated.
A little complicated.
Yeah, a little complicated, but let's not go there. Okay? So C. Alright, we'll go back. Okay, 8. 8 is B, definitely. Okay, let's take a look. A student are trying to do the indicator instead of pH meter. Where, right, if the indicator color change slightly past equivalent point, what will be the students obtain for the calculated concentration of acids? So, you're trying to look at, yes, but you're trying to calculate concentration of acids. So, take a look at this. What is it telling you here, pH is? 8. So it is change at pH of 8. Right? Okay. And if you look at it, how can it give us information about the acid concentration?
The amount of base you have.
Right. Because pH 8 tell you the amount of base that you have to add it. Right? So if you take a look down, how much 8 you added? You added 40 milliliter. Do you see that? That's the information you're gonna use. That's the whole reason why you do that titration. Okay? I haven't quite talked about this yet, so pay attention to this question. So the whole point of titration is to know what is the HA, right? So what kind of concentration HA has. Make sense? So you're looking at the base added, which is in this case NaOH, right? Added. You know that it was 40 milliliter, so I'm going to say 0.04. We're okay with that one, right? I'm changing to liter. Time the molarity, 0.1 molarity. See how it? Yeah? So that will give you concentration, mole, sorry. 0.004 mole of OH minus. Are we okay with this? Which means, remember, that is equal to amount of acid originally have, so that means 0.004 mole of H plus exists originally in a form of HA, right, which is the same thing as HA. And we know how much HA volume in the beginning. If you take a look at it, the question has it 50 milliliter, right? So we can say 0.004 mole divided by 0.05 liter. That will make us give you the answer. Okay, so if you are to move them around, we'll say let's see, 0.4 divided by 5. So, you know, I don't know the map on that one. So if you do the math, about 0.8, yeah. Now, you will get it about 0.08 molarity. Now you're like, well, now we have a problem. We have both A and B are saying 0.08. So how would you know which one is? Okay, so what did they say here? Indicator is past the equivalent point. So that means the moment you know is already past it. So that means the so-called like the 40, that is after, right? So that more, therefore, your acid is probably slightly more concentrated. Okay? Informations, things, right? So, yeah. Make sense? So calculated concentration is slightly more than what you might get, right? Because the actual one you're gonna get is 0.08. But because your indicator is telling you a little bit after, you're gonna get slightly more. Make sense? Because your number of OH here you calculated will be more than this number. It won't be that number. All right, let's look at 9. What do we get for 9? Oh, I think you have a question on 9, yes? Yeah, it should be B. Because, again, remember the curve. Remember what we're looking at. What are we titrating here?
We are titrating.
We're titrating.
Li, H2O.
Right? I mean, think about internal acid and base. Okay? Yes, it's technically not allyl actually, but yes, it is the a type of. Okay? But take a look at it. It's acid, right? Titration. Take a look at where is halfway point or the equivalent point. Equivalent point is over 7. So pH at equivalent point is greater than 7. What is that signal?
It's a weak acid.
It's a weak acid. So in a weak acid, there is a special case to find pKa. How do you find it? Halfway point pH. So since this is about here, halfway point is about over here, right? 12 something. So yeah, it should give you here 5-ish, I would say. Yeah. So remember, weak acid pH is equal to pKa at when? Halfway point. Okay? We all got it. Okay. Easy enough? Look at 10. What would be the best choice for the titration thing? Okay. Remember, look for pH range. That should tell you which way you should use. Okay. So where is the pH change is happening? This short curve. Which region? Well, it's go from about 6-ish to about 12-ish. Okay, and if you look, your halfway point is about 9-ish. Okay, so anything around that area will serve really good one. Okay, so if you take a look at down here, I will eliminate this one and this one. Do you see what I was doing? A and B are gone, so that's kind of get you C and D to go. Which way should you pick? Yeah. Yeah. Right. C is closer. Yeah, because the other one is 12. And if you look at 10, 12 is a little bit over of that range. Okay. All right. 11. What do we get? You don't know that one. Okay. That's okay. Net ionic equation of allyl solid with water. Okay. We got to take a look at it. And we kind of know that it is somewhat of a acid-base titration that is happening, right? So what do you think this is gonna do? Well, they all have allyl solid. That's great. And then, of course, obviously, I'm gonna eliminate A because we're not, we're gonna put in the water. We're dissolving water, and then let's see the list of things that going on here. Okay, which one are we thinking is might be our acid-base reaction? So you kind of like B. It is a B. Yeah, good. Because take a look. C is not possible because remember we talked about this one before. Allyl OH is what? It's got dissociation, right? So okay, good. Glad. Well, okay. See, you guys are slowly thinking. 12. Is C. Let's take a look. Alright. Okay, so let's take a look. To maximize the yield of a certain manufacturing product, a solution of weak monoproduct. Okay, let me first explain this. Monoproduct meaning it's only have one H plus that can give away. So we're dealing with HA, that has a concentration between this and this is required. 400 milliliter sample acid at a different concentration are each titrated with this. Okay, volume of this needed to reach endpoint is given above. Which solution is most suitable for the yield? Okay. All right. So what do you think? Well, the question is asking what? We're looking for concentration between these two. So what do you think you're looking at these questions for? Concentration of in between this range. So let's take a look. These are all milliliter. First, I'm going to say that liter would be 0.04, right? Liter, 0.075, 0.115, and 0.200. Okay. The molarity is given is 0.2 molarity. What do you think you're gonna do? Mole. So that will give you 0.008 mole. Do you know that we have a volume of acid in the question?
Volume of acid?
Yeah. That means the acid volume is 100 milliliters. So divided by 0.1. So then that gives you concentration as 0.08 molarity. Take a look. Is it within the range? No. So you go on to another one and then you find within the range. And if you're looking for C, C will give you within the range of this. Because, let's see, 0.2. This time this will give you 0.023, right? Mole divided by 0.1. So that means that's going to give you 0.23 molarity. 0.23 is within the range of these two that we're looking for. See how it goes? So notice the formula that we're using. In case you're not noticing, this is what I just did. Kind of. Do you see that? Isn't it MV here? That's what I did. Right? Volume, concentration. Right? How do we know concentration? I give it to you right here. Do you see that?
Oh, I get it.
MV for the base is equal to MV for the acid. Except you're looking for your M. Your M has to be in between these two. Got it?
Yeah.
Okay, again, guys, this is what you guys are lacking. You need to learn how to read it. Because technically, did I teach you this? Yeah, I teach you this a long time ago and we keep using this all the time. Right? So know how to read the question. What are they asking? What did they give you? They said which solution is most suitable. And you can see that the solution that is suitable is this. They require this. So that means we want that concentration. Make sense? Question before we go on at 13. Question? All good? Okay, 13 then. Take a look at 13. What's going on? 13 questions on the other side. Damn. All right, okay, that's okay. I will shift both ways. All right, let's take a look. What are we saying? Okay, so at the point R of the graph, which of the following is, okay, well, take a look at R. What does R mean? Equivalent point. So that means what happened to the acid? Neutralize, right? So these two are also what? Strong acid, strong base. Notice. It's S7. Do you guys see that? Right? So this is strong acid, strong base. So this is gone. So who is going to be left behind? Perfect. Right. No H plus, no OH minus. Easy question. Yes and no. Because let's say I'm going to be playing double advocate right now. Let's say instead of I give you NaOH and HCl, right? Let's say I give you FeOH2 or something. No, let's just say, yeah, something like CuOH or whatever, like the one of the weaker one, right? Let's use CuOH. Let's say I have CuOH with the HCl, okay? And we're looking at equivalent point. So equivalent point, okay. We know that acid is going to be gone. H is going to be gone for sure. So we're going to have with Cl minus. Agree? We know that Cu will be left behind as OH will be gone. Right? Now here's a problem with this. What is Cu? Slightly acidic. So that means it's going to go around and bond with the water and it's going to start removing the H from water to make OH minus. So technically, whenever you have this weak character, you will have this back. So because of that, you will have some of the OH minus floating around because it will grab the H out of water and donate it. Okay. Yes. So that donating H make it acidic. This is acid. So this is a weak acid. So it will, remember how we do the weak acid? We have HA. So it's gonna do this. A minus plus like the H plus, right? Kind of. So it will do, what would I writing? Yeah, so it will do this strange thing with the how acids were doing. So it will have another one. So you would look for conjugates and stuff. But anyway, we're not looking for conjugate right now, so don't worry about this in this question. But anytime you have a weak, think about conjugate. Conjugate is gonna play a role. Now I know this is not perfect because this guy create a weird form of acid that we don't really talk about because it will do a complex with water. So anyway, I create a bad example, but okay. 14. B or D? It's either B or D. Okay. Okay. You eliminate down to that. Okay, let's see. Kevin, you have one for 14? D? Okay, so we're debate. Okay, let's take a look. All right. Student titrate the NaOH with this HCl instead of this. Okay, take a look what's happening. Concentration is much more increasing. So what was gonna happen? Well, you are getting more acidic. Okay, so the pH is stronger. Okay, but where is your equivalent point is gonna be? It's still 7, but you need to add less of HCl, right? Agree. So if you take a look at it, you need less of HCl, so that means it's gonna be somewhere here. Let's just say halfway point somewhere here, and then let's say this is the pH here. So you're gonna graph something like this, right? Do you see the example graph? You might have something like that graph. So that graph matches which one of them saying? This matches D, right? Because B is wrong because your equivalent point pH wouldn't change, but your pH would be a little below what it used to be. Look at the curve. It's going to be below of that curve, right? Underneath the curve. Right. Yeah, so it's still going to be 7. All right, let's look at number 5. Ooh. 15, sorry. I forgot one. All right, be nice. All right, what do we get? B. Good. Okay, notice that you don't have to calculate, but it's literally what you're doing. You are adding, right, these two equations, right? And then you're multiplying, yes, because this equation multiplied by 2, right? So if it multiplied by 2, what happened to this? Square. So remember that. If it multiplied by 2, you are squaring this, okay? And then when you're adding, what do? You multiply. So the answer is 2 times 10 to the negative 6 times 1 times 10 to the negative, not negative, 10 to the 6, right? So that will go away. You're going to get answer of 2. So that means your K3 is greater than 1. If it's greater than 1, what does that mean? It's favorable, right? It's going to happen. K1 times K2 squared, because this equation is this one plus 2 times of this one. Because take a look. See? You see that? Yeah. So if you time the equation, you're going to square it. If you add the equation, you're going to multiply it. For the K. Don't forget, Hess's law is different, right? Yeah? K just special. Okay. When I add it, I would multiply the K. When I multiply it, I will square the K. All right. Okay, 16. Is B, yes. Okay, well, get why? Explain. Process of elimination. I love this. All right, but You can tell why it's gonna be more soluble though.
It's a base.
It's a base. Yeah.
Oh, that's all.
More acids, I mean, it's gonna neutralize the OH, make it more soluble, right? Okay, good. Oh wait, we're not done yet. 17, what is this? Is A. Because remember, take a look at KSP value. KSP tell you what?
The ionization.
Ionization. Lower KSP mean more soluble or less soluble? How do you write the KSP equation? Concentration of ions, right? Cations and anion, right? Your plus ion and your minus ion. Agree? That's how you write it. So that means the lower KSP meaning what? The less ion you have, so that means less soluble, right? Okay, so which one we're looking for here? We're looking for a saturated solution which has greatest Cl minus. If I have a greatest concentration Cl minus, are we looking for more soluble or less soluble? More soluble. That means biggest K. Okay, so if you're looking here for biggest K, you're gonna have this, right? Plus also, if I have this one with another one of the same, let's say, for example, if Cu and PbCl2 have the same KSP, still PbCl2 will win. Why? I'm saying that if there's another one, let's say, CuCl with the same KSP as this, still this guy will win. You guys know why?
Oh, because it's
Do you see that? Yeah. Right. So if they have the same KSP, this guy still win. Okay. But in this case, we don't need to care about this. It's already smallest. Okay. I mean, not smallest, the biggest. All right. Let's take a look at number 18. Ah. Okay. What did we get? AC. Yes. Because I told you to? No. Take a look at your KSP again. Right? What did you notice? This is smaller, yes? That means this is most likely to precipitate first.
it's less soluble.
Less soluble. Now, of course, you need to read the more information down here to tell. So if you look at more information down here to tell, it gives you concentration of Ag, it gives you concentration of Pb, and then it's also give you the sample of this is added. So that means you're adding this. What is this gonna give you? This sample is gonna give you what?
Solid.
Which particle is gonna come out of that we're interested in from here? It's come from SO4, right? Minus 2. That is gonna be equal to 0.001 mole, right? The volume is here, 1 liter. Do you see that? So you have concentration on that. You also have concentration on Pb. You also have a concentration of Ag. So guess what you're doing? You're solving for Q. Remember that note? Q and KSP. If Q is bigger than KSP or Q is less than KSP, that's gonna tell you. Okay? So here it just happened to be work for this, but you also have to check the concentration of these. Make sense what I'm saying? So take a look at your Q, right? So for the PbSO4, you are having 0.001 times 0.001, right? But Q for the AgSO4, Ag2SO4, oh, not even 1, Ag2SO4, guess what happening? Ag concentration is 0.2, 0.02 square times 0.001. Do you see that? You calculate this, you get 10 to the negative what? Mental math here.
10 to the negative
6, yeah. Okay, so this is gonna give you 0.0004 times 0.001 Okay, quick mental math here. What is it gonna give you? 4 times 10 to the 7 here, -7. Okay? Because you do 1, 2, 3, 4, 5, 6, 7. Okay? So if you take a look at this number, take a look at that number with up here, AG2SO4. Do you see that how Q is still smaller than K?
Oh,
But
yeah.
here, take a look at your Q and K. Your Q is bigger than your K.
Much,
Do you see that? So that means this will precipitate, whether this won't, because I can still add more. Do you see that?
If Q is equal
That means you're saturated. You're done deal. You won't have any solid, but you're done deal. That means you can't add any more. Okay.
it just sits there. It doesn't precipitate.
It doesn't precipitate. It doesn't dissolve. It is at the equilibrium. So they could be doing precipitating and dissolving, but you don't see it anymore, right? Because they are doing in their own thing. All right. Okay. Look at 19. What do we get? The last one.
Hey,
Uh-oh.
hey.
A is B.
What? Kevin,
Wait, why is CAF stays constant though? I don't care if it's dissolved. It's still there. Are you only measuring solid?
Let's take a look. He's like, I protest this answer. Alright. Okay. Beaker contain 1 liter of solution of this that is at the equilibrium with the end dissolved this. Okay, so they have 2 of them in there. Chemist add this KF into the beaker. The solution stir and the equilibrium is re-established. Which of the following is most accurately represent the change, if any, that is occur in the system after you add in this? Let's take a look. I know why you're confused or what you're saying. Okay, so you are having. I'm just gonna write it like this, cause agree. You're having this in an equilibrium. What is adding KF would do? KF is added.
Increasing F max.
Okay, that means it's gonna increase this. If you increase this, that then again it's gonna shift this way. Which means what? Things gonna start precipitating. Right?
Yeah.
So concentration of Ca plus would decrease. Agree?
Yeah.
You're not problem with this, you're problem with this side, right? Okay. Since it's shifting this way, what can we say about CaF2? Concentrate. Increase. But remember, it's not concentration because these are actually the cloud, the particle. They're coming out of the solution. So that means their number is increasing. Right? Kevin, imagine that after you finish this reaction, you're filtering this and you're measuring CaF2.
Oh, you're only measuring solid?
Yeah. Right? It does say solid here.
Oh.
Just the math.
I pretend that I said PTB.
Yeah. Okay. Yeah, well, we're gonna pretend that, yes. All right. Question? We got it? Okay. How we all feeling after this?
Okay.
Hard.
Hard? It should be easy. Yeah? All right. Okay. You need practice more. Okay.
Yeah.
All right. Let's go through the free response. You guys finish? Or you guys kind of get started? All right.
I've got started, but I haven't finished.
All right. Okay. How about you guys guided me then? We're gonna go through that. You're gonna tell me. If you guys say something wrong, I'll tell you.
Okay.
All right. So, what is this question? What we're telling you?
Ka value.
Okay. Let's quickly take a look at it and then. Okay. Golly. Okay. I can tell people on the cell phone and people are doing good old traditional messaging or writing note on the paper to your neighbor.
Do people still use that?
Yep, they do. Okay.
Class?
Yep. Good luck passing this class. All right. Let's take a look. Okay, guys, come on. Again, I know. We only have a month left. Okay? Just work hard for 1 month and then we're done. Okay? I'll be stopped like nagging.
We can do icebox.
Yeah. Okay, good. We can do ice box.
Yeah.
No? What? What are you on? Okay. So you have solution 1, solution 2, 2 different equation, aqueous, Ka value. So we have Ka. Calculate the pH of the solution 1. Notice that they're only asking for pH of solution 1. You said we're going to do ice baths. Easy. Let's do ice baths. HF is what? Go to H plus F minus, and then what do we say? HF is 1.0, right?
I suck.
These are not there. And then we assume plus X minus X minus X.
Wait, other way around, Michelle.
Wait.
Both of the minuses switched.
Oh, yeah. Oops. Good jobs. Don't do that. That would be bad because you'll get a negative stuff. All right. So you're going to have 1.0 minus X, X, X. That is at E. Okay. I need you guys to write a sentence where you're going to say, I'm going to ignore this X so that I'm going to say that 1.0 minus X is approximately equal to 1.0. Okay. I'm not writing it for the time's sake, but you need to write it.
A full-length sentence.
Yes, a full-length sentence. You're going to say that Ka is small compared to concentration of HF, so that you're going to say X is small enough, negligible enough, to say that 1 minus X is approximately equal to 1. Everybody get what I just said?
Yeah, no.
Okay, if you don't get it, go back and rewind on the video. All right, but I need you to write that down, okay? So now I'm going to write the Ka.
Can I just write X is too small, therefore negligible?
Yeah, but you have to say internal Ka value, because that's how you're able to tell. Okay?
X is... Oh, Ka is much smaller than 1.0.
Yeah, Ka is smaller than concentration of HF.
Therefore, X...
Therefore, X is small enough, negligible. Right?
Okay, I got you.
X squared divided by 1. Okay. All right. People who have done it, you should have your H plus, and then afterward, you should have the pH. Okay. All right. We got it? 1 point what? For the pH. Yes? Close enough. Okay. Careful, read the question.
Yeah, I didn't know.
Did you round it earlier in the H? Okay. Because you're not supposed to round it until you finish at the end.
Yeah, 1.58.
Okay.
Oh, what? Which is the square root? That's the point.
Maybe we have a trouble on the paradise. Let me see. 10 to the negative 4. So negative log of answer.
Mine says 1.583. Michelle, I think it's just a difference in calculation.
I think it's a different calculator.
I'm 1.58.
I'm getting 1.583 too.
Oh my gosh.
So
Will the AP test being us for like a 0.01 off on pH?
probably not. Here's the reason why. Like we've been noticing too, like the AP, like the teacher have been complaining. Some of them even have a same calculator, like exact same one, and then I think there's a year different or something. Somehow one stole more number than the other. So you guys are getting at different numbers. I'm not sure why, but yeah. So I mean, I think now that AP grader are like more aware of it, I think they're fine. Like, cause a bunch of people in that groups are the grader, so they were like, yeah, we'll address that with the, the committee. So we should be okay. Yeah, I think it's a calculator thing. So yes, do your best to round it from what you get from your calculator. So yeah. Plus also, that 0.5 thing, that's a little iffy, because 5 in the AP. AP don't do that, but in the colleges, depending on the classes, you round it 5 half the time. So yes, some people round it to even, some people look at another number, some people round it to odd. So there is a different way of doing this. But anyway, let's go to the next one. So calculate the KB for the F minus iron. Show your setup for calculation in order to receive for force credit. So how do you find KB?
KW divided by KA.
So remember, you do need to show your setup. This time I want two suffix, right? KB is equal to KW divided by KA. So what do we get? Let me double check. All those, I somehow doubted that we'll have a different, let's see. Yeah, 1.5 what? That's the important part. Make sense, guys? So make sure you include it there. Okay. Just so you know, did K have a unit?
No.
No. So don't accidentally write M, okay? I know sometimes people are habit. Okay, so find a pH of a solution 2 and show the steps. So how will you find a pH of solution 2?
Icebox again.
Icebox again. Okay, so icebox again, in this case, you are doing F minus, going back and front, H plus, and then, wait.
Oh my god.
Wait, no, so
Hold on, I wrote it wrong.
Yeah.
So what is F minus is gonna do? It's gonna take an H from who? Water. Add that guy, yeah. Whenever you notice that you couldn't write it, go back and bring up our friend water, okay? Our friend water is there to help us write the equation. So that will be HF plus OH minus. Agree? There you go. Alright, so now we can do it. Now water is not part of the icebox. Remember that one? 0.8 minus x plus x plus x. So we're going to say 0.8 minus x, x, x. And remember, I need a sentence of assuming that it was just 0.8. Okay? Before you can calculate it. Once calculated, you're going to get what? Then you're going to do the KB equation. And then you're going to solve. When you solve it, what are you going to get?
Are we gonna take into account the HF?
Yes.
Because that's just going to be x. And also we're looking at the solution too. So,
Okay. A.
okay guys, let's solve it.
Is
Your turn. I'll have an answer, but I'm not going to do all the work. Because that's not fun. Alright? Not fun if I do all the work. Okay, what do we get? Oh, it should be basic, yeah. And 2 decimal places, please.
So who set the 2 decimal places standard? Who?
For the pH and POH is a 2 decimal place standard because decimal place equals suffix.
Who set the standard?
Because I think it's because they only change on those two, so yeah. I think it has to do with pH scale. You know, you had to put a lot to change that decimal places. So the fret number is not significant, at least that's how they calculate it as. So what do we get for pH, guys?
8.54?
Okay.
Oh,
we
I agree.
using like the same KA?
What are we using? Okay, solution 3. You'll prepare by combining 500 milliliter solution 1 with 500 milliliter solution 2. Calculate the HF and F minus in a solution 3. Assume that volume of this solution is equal to 1 liter. Of course it is.
Oh, we just have the.
Yeah.
Good. People got it? It's gonna be half of the concentration because you're putting equal amount. So you're diluting basically. So that will be 0.5
Yes.
and then 0.4. See, easy. Yes? Although I will probably keep the suffix. Make it 2 suffix, right? Okay. Got it? Can I go? Alright, I'm going. Okay, E. pH of the solution 3. Show how to do it. Well, guess what? You have a concentration. Let's get started. Let's try how to do it. So you're going to write HF equation. What is HF equation? H plus plus F minus. Except now your initial is different. Your initial is 0.5 and then the other one is 0.0. Wait, is it 0.4 or 0.04? 0.4. Okay, agree? Yeah? So since this guy has nothing, what do you think we're going to do? So we're going to do plus on this side, right? Plus x minus x. So you're going to have 0.5 minus x, 0.4 plus x. Guess what you're going to do after your icebox in this case again? Ignore, right? The assumption rule, okay? You're gonna say that we're assuming 0.5 minus x is 0.5. We're assuming that this is 0.4. Okay? Make sure you write a sentence, please. You're gonna say that Ka is smaller than the concentration of HF and F minus, that we're gonna assume that X is very small, that is negligible. Make sense? Don't forget that sentence. Okay. Now here, do we use Ka or Kb? And tell me why. Ka, why? Right, I write the acid equation. This is the acid equation. Okay? K, x times 0.4 divided by 0.5. Again, I assume everything off. So I'm having Ka equation. I need to go back and look at Ka, which is 6.8 times 10 to the negative 4. Okay, so what is going to happen? Again, guys, follow with me. If you don't have a calculator, you can use it, or you can go on your phone and get those numbers. So what do we get? Your pH is what do you get?
3.0.
Yeah, 3.07. Good. Okay. Last case. What happened if I were adding HCl into solution number 3? Well, solution number 3 is up here, right here. What is solution number 3?
Let me see. It's gonna be.
What is solution number 3 has?
It has some H plus and S minus.
Right. So what HCl is gonna do?
It's gonna dissociate.
Yes, it's gonna dissociate, and then it's gonna react with who?
It's gonna react with F minus.
Perfect. That's all we're gonna write.
Okay.
So F minus plus H plus is gonna go to, right? That's what it's gonna do. Make sense? Question? Now, if you add a strong base, that's gonna be a different problem, right? Then your OH would react with HF, and then we're gonna do this stuff. Okay? All right. Solution 4. You're prepared by adding 4 milliliter of this to a 1 milliliter of solution. Okay, now we're changing things. Calculate the concentration of this. Okay, we're gonna calculate the concentration. All right. Assume that Okay, I'm not sure why we're assuming that, but okay.
Let's
Oh,
just
because
assume.
adding that would change the volume of black and whatever
Yeah, but except I don't know why I want you to assume this. Yeah, I'm gonna delete that one.
you have. Oh, it's because it's used.
Let's delete the whole question.
No, not the whole question. No, I know why I'm asking you guys to assume it, because it's make the concentration calculation a little bit easier.
Come on.
Because 1 liter, and then this is 4 milliliter, right? 1 liter is 1,000, so 1,004 milliliter. Like that 4 is like small enough. Because remember, your total volume would be 1.004 liter, which is, they said, is approximately equal to 1.00 liter. That's what they're doing. Do you see the question?
Yep.
Yeah, that's why they say this is assumed. But yeah, okay. Let's take a look what happening. Okay, since they asked us to assume, I'm gonna be easily able to subtract things. Okay, so let's take a look at here. So I have a concentration of, well, let's talk about initially. What is the concentration of HF initially?
HF initially.
As solution 3, 0.5, right? So 0.5.
0.5.
Okay, what is the F minus solution initially? 0.4. Okay, let's take a look at this one. How much molarity of H do we add it? 10 molarity time. Well, so what is the concentration here?
10 times
0.04?
Liter.
Not liter. You mean mole.
Oh, yeah.
Because liter time molarity, right? Yeah? Agree?
Yeah.
Okay. So since we're gonna put it in the water, I mean in this solution, and we're gonna assume that total is 1 liter, that means I can say from then on, I can say I'm essentially adding 0.04 mole. Can I say that? Because I'm gonna assume that the new volume is 1 liter. Right? Because we're saying that new V is 1 liter. Okay? Make sense? If not 1 liter, it's easy. You just gotta divide this by this number, 1.004, which is essentially 1. Okay, so that's what we're saying. So we're gonna have that. So what is HCl gonna do? You guys already said it before. What is it gonna do? React with F minus, so it's gonna increase or decrease this number. Decreases, so it's gonna decrease by that much, right? So you're gonna say 0.4 minus 0.04. Agree? Yeah. So that means 0.36. Make sense? Okay, how about on this side? Increase. Okay, goes back on here. Finn, you okay? Getting head hurt? Alright. 0.5, right? 0.4, 0.04. So you see you're gonna increase. Right, 0.5 plus 0.04, 0.54 molarity. Now here's the thing though. The only reason I can do it this way is because we're assuming volume. Now you might say, Michelle, what if we're not assuming volume? How would we solve it? Okay, if you're not assuming volume, here's what you're gonna do. Change it all to mole. You're gonna get your initials, right? Change it all the way to mole. Okay? You're gonna figure out your change it all the way into mole, and then you're gonna calculate everything plus or minus whatever it was into a mole. Once you get your mole, what you're gonna do? Divide it by volume, the total, of course, to get the molarity. Make sense? But in this case, I'm assuming this, so I can just kind of like quickly go through that and just subtract it. Otherwise, here when you're subtracting, you're not subtracting molarity, you're subtracting mole. Make sense? Annie, you okay? You look like you're like, I'm lost. Okay.
I'm lost.
Alright. Yeah, come on, Kwan. Alright. Okay, let's look at H. pH of the solution